Hi, this is Aishwarya. I'm currently working as an assistant professor in the Department of ECE at SNS institutions. I welcome you all for this session. Is about arithmetic operations in 8086. So in previous session we will discuss about the two operations, that is addition and subtraction. In this session we will discuss about the multiplication and division operations. So let us go to the program. So this is 16-bit multiplication program in 8086. Okay. So initially we have to start the program and we will get the value of the multiplicand and multiplier. Then multiply the value and get the result, and so store the result into the address, then halt the program. This is the overall function. So this is the first instruction. We have to get the input value from this address 1200. Okay. So this is the first address. This is the multiplicand. So we have to store that value in AX register. Okay. Next one is multiplier. So that value is from 120 address. We will get from 120 address. Then that value is moved to BX register. Then we have to multiply the AX and BX value. Again, the value will be stored in AX register, that is accumulator. Okay. So I just assume in this value as 2 and in this address have the value as 4. 4 into 2 is 4 2s are 8. So that result is stored in AX register. Okay. So it is in 16-bit multiplication. The value of lower order result is stored in 1206 address. Okay. So then the higher order address is copied to AX register. Then we have to move that higher order value in 1208 address. Then halt the program. Okay. This is the process of multiplication program. So initially we have to get the multiplicand and multiplier value from this 1200 and 1202 address. Then we have to multiply the value. That answer, that is the result, is stored in 1206 and 1208. Why? Because the lower order address is stored in 1206 and the higher order address is stored in 1208. Okay. Then we have to halt the program. Same as in division program. In this division program, we have to additionally add one condition, that is in this second stage. In this second stage, we have to get the dividend in two from two addresses. So for what means the 16-bit value. Okay. So move dx comma 1201. We just assume that. Okay. So we have to additionally add this instruction in division program. So we just change the function. We just change the function as div. Div means division. Okay. And we have to neglect this condition because we have to store the remainder and quotient directly into address. We don't have that copy and additional instruction. Okay. So this is the process. So in this instruction multiplication, we know that the values get from address and multiply that value and we have to store the result into the address. Okay. In division program, we have to get two dividend. So in AX we have to get from 1200. So in this condition, next instruction is move dx comma 1201. Okay. Second dividend get from 1201 address. Then we get a divisor from 1202 address. Okay. And then we have to divide the value of AX, DX and BX value, register, and the result will be stored in AX register. Okay. So both the remainder and quotient. So in this condition, the value. So I just put only 4 by 2. This is the LSB value, this is the MSB value, and this is the divisor. Okay, I just only put 4 by 2. So the result 4 by 2 means what is this? Remainder and quotient value is there. So the remainder value is stored in AX register. We have to move that value into 1206 address. Okay. Then the quotient value is in again AX register. That value is moved to 1208 address. We have to halt the program. So this is the process and operation of division program. Okay. So in arithmetic and logical function, we have addition, subtraction, multiplication, division function. So the 4 functions were discussed in this video, and next one is about logical operations. Thank you.